Okay, the current question says the lines 1 minus x upon 2, y minus 1 upon 3 equals to z upon 1, and another line 2x minus 3 upon 2p, y upon negative 1, z minus 4 upon 7 are perpendicular to each other. Under this condition, we need to find the value of the unknown p. Okay, so if we observe, the general equation of a line is x minus x1, y minus y1, z minus z1 whole upon a, b and c. Okay, so in this case, your x1, y1 and z1, that represents the passing point of the line, the passing point of line, and the numbers in the denominator a, b and c, these represents direction ratios of line. Alright, but your line must be in the standard form. Okay, so this is the standard form, but the current line which is given to us in the question, that is not in the standard form. So if I rewrite the line, coefficient of x must be a positive number. So I'm going to take a negative number common. So it is minus of x minus 1 upon 2, y minus 1 upon 3 and z minus 1. That gives me that x minus 1 upon negative 2, y minus 1 upon 3 and z upon 1. Now this is the equation in the standard form. Similarly, I can write the next equation. Second equation is 2x minus 3 upon 2p equals to y upon negative 1 equals to z minus 4 upon 7. Alright, so if I write the equation in the standard form, it is going to be 2 times. So what I need to do, I need to make coefficient of x as 1. For that, take 2 common outside, so it will give you x minus 3 by 2 whole upon 2p equals to y upon negative 1 equals to z minus 4 upon 7. Okay, so remember, your line is in the standard form if the coefficient of x, y and z is positive 1. Now in this case, the direction ratios are, or you can also write this thing as x minus 3 by 2 upon p, y upon negative 1 and z minus 4 upon 7. Okay, so what are the direction ratios of first line? It is minus 2, 3 and 1. Direction ratios of second line are p, negative 1 and 7. So from the direction ratios, I can write b1 vector. This is going to be minus 2i cap plus 3j cap plus k cap or 1k cap. And similarly, b2 vector is pi cap minus j cap plus 7k cap. This is your b2 vector. So what is the given condition? The two lines are perpendicular to each other. So since the two lines are perpendicular, so we have, according to question, b1 vector dot b2 vector is equals to 0 because lines are perpendicular to each other. So if I take the dot product of b1 and b2, you know how to take dot product. I with I, this is going to be minus 2p. J with j, this is minus 3. 1 with 7 plus 7, this is equals to 0. Now if you solve for the value of p, what are we going to get? On solving, minus 2p is equals to negative 4, so p is equals to 2. That's the answer to the current problem. Alright. Okay. The current question says find the equation of a line passing through the point 2, negative 1 and 3 and perpendicular to the lines. Again, the most important part is that the given or the required line, the required line is perpendicular to the two given lines. The first line is I cap plus j cap plus k cap plus lambda times 2i minus 2j plus k, and this is the second line 2i minus j minus 3k plus mu times I plus 2j plus 2k. Now in the current question, you can observe that the line are written in the vector form. This is the vector notation of the line. What is the vector notation? R vector is equals to a vector plus lambda b vector. Okay, so this is the theory part that you need to understand before you start with the question. In the vector equation, this a vector represents the passing point. Okay, so in fact I can say position vector of passing point. And what is b vector? This b vector represents the direction ratios of the line. Direction ratios of the line. So you need to understand this thing. This is the most important part when we observe the line in the vector form. Okay, now comes the condition. The condition says that your line is passing through a random point. The point is, let's say this point P is given to us 2, minus 1 and 3. Okay, in 3 dimension, this line, this is the required line whose equation you need to find out. So if I want to find equation of a line, even in the vector form, what I need? A passing point, let's say a vector in this case, and b vector as the direction ratio. So in the current question, since your given line is perpendicular to the two given line, like this is perpendicular to this and this may be perpendicular to another line. In 3-dimensional, you can always observe two lines like this, okay? So it's a 3D model. It may not look like these two lines are not parallel, but in space, we can always have a line which is perpendicular to more than one line, okay? Multiple lines. So how to find the direction ratios of the required line? So you can see this is the required line whose equation I need to find out, okay? Now let's say B vector be the direction ratios of the required line. Okay, so represent the direction ratios of the required line. Let me remove this thing. How to find B vector? Okay, B vector, as per the condition, the required line is perpendicular to the two lines. This is line 1 and this is line 2. So B vector, okay, so B vector supposed to have two vectors. One is along this arm and another is along this arm. So if I want to find a vector which is perpendicular to both of these, that is given by the cross product of these two vectors. So B vector is nothing but B1 vector cross B2 vector. Okay, what is B1 vector? It is the direction ratio. It represents the direction ratios of the first line, and B2 vector represents the direction ratios of the second line. What is B1 vector? 2i cap minus 2j cap plus k cap. And what is B2 vector? I cap plus 2j cap plus 2k cap. So this is B1 and B2. I want to find B vector, which is cross product of these two. This is the definition of cross product, that once we take the cross product of two vectors, okay, so B1 cross B2, I'm also writing this part, B1 cross B2 is a vector perpendicular to the plane containing both B1 vector and B2 vector. Okay, so if someone asks you that given two vectors, how to find a vector which is perpendicular to both of those vectors, you simply need to find the cross product of the vectors. So how to find cross product? For the cross product, we know that we need to find the determinant whose first row has I, j and k, and the second row has components of B1, which is 2, negative 2 and 1. The third row has the components of second vector B2, which is 1, 2 and 2. Okay, so this is going to be I times, leave the row, leave the column. This is minus 4, minus 2, minus j cap, 4 minus 1, and plus k cap, which is 4 plus 2. Let me remove this thing. Okay, so this is going to be negative 6 I cap, negative 3 j cap, and plus 6 k cap. So I can say that B vector is given by negative 6 I cap minus 3 j cap plus 6 k cap. Okay. So this is the direction. This represents the direction ratios of the required line. So hardly one more line to write the final answer. Let's write it over here. Direction ratio, therefore equation of the required line is R vector equals to A vector plus lambda B vector. Since the question involves lines in the vector form, we are also going to give the answer in the vector form. So in this case, what is A vector? It is the position vector of the passing point. You know how to write a point into a position vector form. This is A vector plus lambda times B vector. What is B vector? Negative 6 I cap, negative 3 j cap plus 6 k cap. Okay, so that's the final answer to the given question. Okay, the current question, it says find the shortest distance between the lines whose vector equations are given by R vector equals to I plus j plus lambda times 2i minus j plus k, and the second line is R vector equals to 2i plus j minus k plus mu times. So you're given two lines. Now first of all, if you observe the formula for this one, the theory part says how to find shortest distance between two skew lines. Find shortest distance between the two skew lines. If D represents the shortest distance between two lines, then it is given by A2 vector minus A1 vector dot B1 cross B2 whole upon B1 vector cross B2 vector magnitude and whole mod of this thing. Okay, so this is the formula where A1 represents the passing point of your first line. This is A1 vector, this is B1 vector, This is A2 vector, which is the passing point of the second line, and B2 vector represents the direction ratios of the second line. Okay. Now we simply need to find out the values. What is A1 vector? I cap plus j cap. A2 vector is 2i plus j minus k cap. So therefore I'll have the value of A2 vector minus A1 vector as 2i minus I cap, j minus j plus 0 j cap, and minus k cap. So this is I cap minus k cap. And B1 vector cross B2 vector. You know how to find cross product of two vectors. Your first row is I, j and k. Your second row is 2, -1 and 1, which are the components of B1 vector. And your third row, is 3, -5 and 2. Alright, so let's evaluate this thing. This is going to be I times, leave the first row, leave the first column. This is -2 plus 5 minus j cap, leave the first row, leave the first column, 4 minus 3 plus k cap, leave the row, leave the column. This is -10 plus 3. Alright, so this is going to be 3i cap minus j cap minus 7k cap. So this is your B1 vector cross B2 vector. Now simply plug in the values for the shortest distance. Shortest distance. What is the formula? A2 minus A1 dot B1 cross B2 divided by mod of B1 cross B2 and whole mod of this thing. Okay, so this represents the magnitude of the cross product of two vectors, and this represents that the distance is a positive quantity, so it will make the overall value positive. So let us substitute the values. So I minus j dot 3i cap minus j cap minus 7k cap divided by magnitude of 3i cap minus j cap minus 7k cap and whole mod of this thing. You know how to take the dot product of two vectors. This is going to be 3 plus 1 plus 0 plus 1 plus 0 divided by root of 9, 3 square, which is 9, plus 1 plus 7 square is 49. Okay, and whole mod. This is going to be 4 upon root 59. So that's the shortest distance between these two lines. Okay, now there is an important note or remark. What is the remark in this question? If B1 cross B2 turns out to be a zero vector. Okay, this means that B1 vector is, this means that the lines are parallel to each other. So therefore lines are parallel to each other. Now for parallel lines we have another concept. What is the formula to find shortest distance between parallel lines? It is given by A2 minus A1 cross B vector. You can take either B1 as B vector or B2 as B vector divided by mod of B vector. Okay, so I can write B1 over here and B1 over here and then whole mod. Okay, so instead of dot यहाँ पे cross आ जाएगा और नीचे उसी vector के magnitude से आपने divide करना है. ठीक है. So in case B1 cross B2, so that's a trick, or that is just an observation, that if the cross product of B1 and B2 turns out to be 0, the lines are parallel, and in that case you need to use the formula to find shortest distance between parallel lines. Okay, the current question is find the length and foot of the perpendicular drawn from the point 2, -1, 5 on the line x minus 11 by 10 equals to y plus 2 by -4 and equals to z plus 8 by -11. The line is written in the Cartesian form. Okay, let us try to plot and analyze the situation graphically. This point is say P, from where I need to find the foot of the perpendicular on the line this. This is x minus 11 upon 10 equals to y plus 2 upon -4 equals to z plus 8 upon -11. Okay, so this is the equation of line on which we need to find the equation foot of the perpendicular. All right. Now just observe, if I draw this situation graphically, this is the, let's say, foot of the perpendicular, and let's say we mark this point with Q. This is point P and this is perpendicular to line AB. Okay, so I'm marking this line as AB over here. Easy for you to analyze and observe. Now just observe, we know that this is a line and we can always assume that, let's say, this is equals to some lambda. Okay, so in terms of lambda, if I find out any point, you have to start your solution like this. Any point on AB is given by this point is Q, and the coordinates are, if you equate this with the lambda, what will be the value of x? 10 lambda plus 11. Okay. Similarly, if you equate this with lambda, it will be negative 4 lambda, negative 2. And if you equate this with lambda, it will be negative 11 lambda, negative 8. Okay. So these are the coordinates of the point Q in terms of lambda. Now, once I have the coordinates of Q, you can always find the direction ratios of PQ. Okay, so or you can say you can always find PQ vector, which is given as OQ vector minus OP vector. This is how you find direction ratios of a line passing through 2 points. Why I am finding the direction ratios? Because you are given that PQ is perpendicular to AB, and we know that if two vectors are perpendicular, then the dot product of their direction ratios is 0. So as per this condition, it is going to be 10 lambda plus 11 minus 2. Okay, I am finding the direction ratios. So let's put them into a bracket form. 10 lambda plus 11 minus 2. Next is negative 4 lambda negative 2 plus 1. I am using OQ minus OP. And minus 11 lambda minus 8 negative minus 5. Okay. If I simplify this thing, this is going to be 10 lambda plus 9, negative 4 lambda minus 1, and negative 11 lambda minus 13. These are the direction ratios. Now from the direction ratios, I can always have a vector. And simply, what is the condition? According to question, as if we observe, PQ is perpendicular to AB. Okay, PQ vector is perpendicular to AB. Line कह सकते हो आप इस केस में. So therefore, direction dot product of their direction ratios is 0. All right. So let us try to apply this condition. And what I have over here, 10 lambda plus 9 times, what is the direction ratios of AB? We know that the lower numbers in the equation of the line, that represents the direction ratios of AB. So it is 10, negative 4 and negative 11. Then negative 4 times negative 4 lambda negative 1 and negative 11 times negative 11 lambda negative 13. This represents the dot product of direction ratios of PQ as well as AB, and this is equals to 0 as per the conditions. If I simplify this thing, 100 lambda plus 90 plus 16 lambda plus 4 plus 121 lambda plus 143, this is equals to 0. Club all the terms containing lambda. 100 plus 16 plus 121, this is going to be 7, 3 and 2, 237 lambda. If I add the rest of the numbers, 143 plus 90 plus 4, that is again 237 plus 237, this is equals to 0, and therefore lambda is equals to negative 1 after simplification. So once we have lambda as negative 1, I can find the coordinates of foot of the perpendicular. So foot of the perpendicular, हमने किससे मार्क किया? Point Q. Q is the foot of the perpendicular over here. You can see in the diagram also. Q is given by, if you substitute lambda equals to negative 1, क्या बनेगा? यहाँ पे lambda की वैल्यू negative 1 put करें, 10 times negative 1 plus 11. So this is 1. Similarly, if I put lambda as negative 1 in the y coordinate, that will be plus 4 minus 2. So it will be 2. And if I put lambda as negative 1 in the z coordinate, it will be 11 minus 8. That is 3. So 1, 2, 3, this represents the foot of the perpendicular, and that's the answer to the current question. Okay. Now next is the length. So आपने question में देखा होगा, find the length as well as the coordinates of foot of the perpendicular. So once I have the coordinates of foot of the perpendicular, I simply need to find length and the formula for distance between two lines. That is what we are going to use. So I'm going to remove this part, and let us also find the distance between, or the length of the foot of the perpendicular. So length of perpendicular means PQ vector and whole mod. This is going to be x2 minus x1 whole square. This is the formula that I am writing, plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the formula that you need to apply to find the distance between 2 points. And as per the question, it is going to be 2 minus 1 whole square plus minus 1 minus 2 whole square plus 5 minus 3 whole square. That is going to be 1 square plus 3 square plus 2 square. that is 1 plus 9 plus 4, which is going to be root of 14. So root 14 is the length of the perpendicular. So both of these parts are over, and this whole entire question is important. Make sure to properly solve it and revise it again and again. Okay. So, okay, the question is find the coordinates of the foot of the perpendicular and length of the perpendicular drawn from the point P 5, 4 and 2 to the line r vector as minus I cap plus 3j cap plus k cap plus lambda times 2i plus 3j minus k cap. Also find the image of the point P in the line. Okay, so the question which involves foot of the perpendicular in a line as well as image of the point in the line, that is really important. Okay, it comes under 5 marks in board exams, so make sure to properly observe as well as analyze the whole situation. Okay, so let's once again draw the graphical representation of this thing. That what is the situation given to us? A point, image of P. A point P is given to us. The coordinates of P are 5, 4 and 2, and this is a line where I need to find the image. Okay, so I also need to find the foot of the perpendicular as well as the image. So let us say Q is the foot of the perpendicular and R is the image. R is the image. Let's say image is alpha, beta and gamma. Now what is the condition of image? That image is at the same distance from the mirror as the point is from the mirror. Okay, so this line is acting as a mirror where I am finding the reflection of point P. Okay, so R is the image and P is the point. Q is the foot of the perpendicular. Now let us say this line is AB. Equation of AB is already given to us. This is R vector as minus I cap plus 3j cap plus k cap plus lambda times 2i cap plus 3j cap minus k cap. Okay. Now, easy way to understand the question if you convert the question in the Cartesian form. Okay, Cartesian form में अगर मेरे को line की equation लिखनी है, so line equation is x minus x1 equals to y minus y1 equals to z minus z1 upon ABC, which is the direction ratios 2, 3 and negative 1. So it is x plus 1 upon 2, y minus 3 upon 3 and z minus 1 upon negative 1. So this is the Cartesian equation of the line. Try to analyze. Easy way to understand a question is if you understand the question in terms of x, y and z, यानी कि Cartesian form में. अब अगर आपको Q points, any point Q on above line is given by, if you equate this equal to lambda, let's say what is going to be x? X equals to 2 lambda minus 1. Then y is equals to 3 lambda plus 3. And z equals to minus lambda plus 1. Okay, so these are the coordinates of point Q. I hope this thing is clear, but this point is in terms of lambda. What I need to do, I need to find the value of lambda in order to find the exact coordinates of Q. What is the condition? Condition is that PQ is perpendicular to AB. So what I need next is direction ratios of PQ. How to find direction ratios of PQ? It is given by x2 minus x1, y2 minus y1, z2 minus z1. This represents the direction ratios of the line. This is the formula. Now if I apply the formula, this is going to be 2 lambda minus 1 minus 5. Next one is 3 lambda plus 3 minus 4. Next one is minus lambda plus 1 minus 2. Okay, so if I rewrite direction ratios of PQ are in the simplified form 2 lambda minus 6, 3 lambda minus 1 and minus lambda minus 1. Now PQ is perpendicular to AB. Okay, if two lines are perpendicular, we know that dot product of their direction ratios is going to be 0. Now directly dot product लेते हैं. यहाँ पे नीचे क्या है? AB की direction ratios are 2, 3 and negative 1. जो आपके पास lower numbers हैं वो direction ratios होंगी. So I can say according to question, if these two lines are perpendicular, so I can say 2 times 2 lambda minus 6 plus 3 times 3 lambda minus 1 minus 1 times minus lambda minus 1. This is equals to 0. Okay, where this 2, 3 and negative 1, these are the direction ratios of your line AB. If you simplify this thing, this is 4 lambda minus 12 plus 9 lambda minus 3 plus lambda plus 1 equals to 0. 4 and 9, 13 plus 1, 14 lambda, and again minus 14 equals to 0. So that gives me lambda equals to 1. So mostly in whenever such questions comes, lambda value of lambda is either 1 or -1 in most of the questions, but not necessary. So lambda is equals to 1, and therefore coordinates of Q. What is Q? Q is your foot of perpendicular. They are given by, कहाँ put करनी है आपने lambda की value? In the coordinates of Q. Q हमने यहाँ पे लिखा है, this is our Q. So lambda is 1. 2 minus 1, 1. 3 plus 3, 6. I'm substituting the value of lambda as 1, and the z coordinate is 0 over here. Okay, so 1, 6 and 0, that represents the coordinates of foot of the perpendicular. That solves half of our question. अभी देखो foot of the perpendicular coordinates से length of the perpendicular चाहिए. Length PQ is given by, क्या फॉर्मूला था? x2 minus x1 whole square, y2 minus y1 whole square and z2 minus z1 whole square. ठीक है, p आपके पास है 5, so this is 5 minus 1 square plus 4 minus 6 square plus 2 minus 0 square. This is going to be 4 square 16, 2 square 4 and 2 square again 4. That is going to be root of 24, which is nothing but 2 root 6 units. Okay, whatever are the units. So this represents foot of the perpendicular as well as length of the perpendicular. So half of the question now it is over. The next part, which is hardly of 2 lines, is left out, and that is to find the image of the point in the line. Image of the point P. I'm going to remove this part, but I'm going to keep the diagram over here. Okay. Let's remove this thing if it is possible. Okay, I'm simply going to remove this part. R is the image, let's say alpha, beta and gamma. So I'm mentioning over here that we are finding image of the point, image of P in line is R, alpha, beta, gamma. Okay, so what is the key point to observe over here? Notice Q is midpoint of P and R. Okay, as per the definition of reflection, Q is the midpoint of P and R. So midpoint formula says x1 plus x2 by 2. So alpha plus 5 upon 2 is equals to x coordinate of Q. Q का x coordinate क्या है? This is 1, 6 and 0. This is equals to 1. Beta plus 4 upon 2. This is equals to 6, and gamma plus 2 upon 2 is equals to 0. So that gives me alpha equals to -3, beta equals to 12 minus 4, 8, and gamma equals to -2. So -3, 8 and -2 is image of P in the line. Okay, so that completes the entire solution to the given problem. Make sure to properly analyze the whole situation. This question comes under 5 marks in your board exams. All right.